Hi. In this video, we will explain basic structure and architecture of an UVM environment. Before starting, I am assuming that the viewer has the knowledge of what is UVM, or Universal Verification Methodology, and the purpose and advantage of it. If not, please watch my previous videos about the same. So let's start. We will first classify UVM test bench into two. First, instructions, and second, actions for each instructions. As a test bench, user gives a set of instructions to it, and the test bench takes corresponding actions for it, without the need of a further user interaction. Actions will be executed by different block, like in any other test bench. Instructions can be any informations, or commands, or maybe even configurations, for the design and test bench and its blocks. Test bench should be able to drive DUT ports, according to instructions from user, and sample output from design, for comparison, and a self-checking mechanism, to check the sampled data continuously. UVM has class library, for taking care of all these requirements. Set of instructions are of basic class, UVM object, and the block, working on the instructions, are components. From class UVM component, informations are generally added to the extended class of UVM sequence item, or UVM transaction, and commands for the test bench is provided by user are kept in extended class of UVM sequence. Considering the reusability of test bench, it is a good practice to keep UVM environment configurable. It may be either timing details or option to configure environment to act as transmitter or receiver. All this configuration informations can't be provided in the extended class of UVM config. Driving DUT ports are done from component driver, which need to extend from UVM driver, and this driver need to parameterize with the corresponding transaction item or sequence item, according to which this component drives signals to interface. UVM driver has an option to send information back from DUT interface to user. Sampling design signals are done using monitor. It can be extended from UVM monitor. There is no major difference between UVM component and UVM monitor, but it is a good practice, considering UVM is constantly improving, and there is a potential feature additions to all the class library. Self-checking for sampled signals will be done in scoreboard, which can be extended from UVM scoreboard. These are the major UVM base classes, not all. So, let's see how we can use this to make UVM environment. Basically, like any other SV test bench, we have the design and an interface connected to it. We will use the sequencer, which takes sequence from user, which contains the information for test bench to drive, and the information will be provided to driver, which in turn drives the sequence to interface ports. And we have monitor, which samples data from interface ports. So here we have components for driving and receiving. Basic purpose of test bench. We group all this in one component, and it is agent. So, let's talk about the purpose of agent. We have a design with n number of ports, using a driver to drive all of them, and a monitor to sample all the port signal. It can be done, but every design will be having some common ports. Let's say the PD, the HP, the XI, or I to C, or any common ports. If we write logic for driving all these ports in one driver component, it can be used for one particular design, and maybe for the derivative of the same design, with some tuning in both design and test bench. Instead of that, if we group all the ports in too many, and write separate driver monitor for each of them, we can reuse those without any addition across designs. We get the advantage and flexibility of plug and play. This driver monitor set together in agent can be reused. So, instead of one agent, we use different agents, which take care of different DUT ports. All this agents will be instantiated inside another component, and it is environment, which also instantiates scoreboard. which takes packets from different monitors and does necessary comparison. This environment also does the basic configuration for all the agents. Environment will be instantiated inside the test. User will be interacting with the test and without need to know the micro-implementation inside each agents. And each of these components will be communicating through another mechanism called ports. TLM ports. Please watch my video on the same for the details. Thanks for watching.